All right, so homework 13, we are just going to rearrange our formula that we've been using. Our formula said that z was equal to x minus the mean over the standard deviation. What they're going to do is take this formula and solve it for the standard deviation instead. And when I do that, that basically is just going to switch these two symbols around. So my standard deviation is going to be equal to x minus the mean over the z. So that's the way we're going to do it on these problems. It's the same formula, just rearranged. It says, suppose that the lifetimes of tires of a certain brand are normally distributed with a mean of 74,000 miles and a standard deviation of, we don't know. The tires come with a 65,000 mile warranty. The manufacturer of the tire can adjust the standard deviation during the production process. By the adjustment of the standard deviation, it is quite costly. The manufacturer wants to set the standard deviation once, so that for all, so that only 5% of the tires will fail before the warranty expires. Find the standard deviation to be set. So first of all, they're giving us that we want 5% of the tires, or only 5% of the tires will fail. We actually want then to find the percent that are going to pass. If 5% will fail, then 95% are going to pass, right? So we want to find the standard deviation. And so our x value is going to be the 65,000 mile warranty minus the mean, said was 74,000 here, over z sub 0.95, since we want 95% of them to pass. And that's what we're going to put into our Alex calculator. Again, either you may have to put parentheses around this, or just hit your equals first so that you can figure out that top number before you divide. Oh, and then divide it by your z sub 0.95. Ooh. And we are rounding these to 1 decimal place. What do we come up with when we go to 1 decimal place?
5471.7.
I might have rounded it more off than you. We'll go with that. I think it does give you a little leeway on that rounding, because it depends if you round off in the middle of the problem or not. Oh, no, it should just be 0.6.
0.6.
That's what I had. Okay. Because it's 6.1, right?
Oh, yeah.
So it should just be 0.6. Okay. And so number 2, this is going to be the same kind of thing. Suppose the lifetimes of a tire of a certain brand are normally distributed with a mean of 74,500 miles and a standard deviation of, we don't know, miles. The tire comes with a 55,000 mile warranty. The manufacturer of the tire can adjust the standard deviation during the production process, but it's quite costly. The manufacturer only wants to set the standard deviation once, so that only 10% of the tires will fail. So if 10% will fail, what percent will pass? 90%, yep. So, whoops, 90% will pass. So, our standard deviation is going to be equal to, the warranty was at 55,000 miles, minus the mean, which was 74,500 miles, over z sub 0.90. And we're rounding our answer to 1 decimal place once we get our answers. No, I think that's way off. So do your top number first. Take your 55,000 minus your 74,500.
Oops.
74,500 equals. Now divide it by your z sub 0.90. There, that looks better. So our answer to the nearest, or to one decimal place, would be
215.9.
15,215.9. Yep. All right. Third one's pretty much exactly the same as the previous two. Suppose that a lifetimes of tires of a certain brand are normally distributed with a mean of 74,000 and a standard deviation that we don't know. The tires come up with a 55,000 mile warranty. The manufacturer can adjust the standard deviation, but it's quite costly, so they only want to do it once. We want to find it so that only 1% of the tires will fail. So if 1% of my tires fail, what percent passes? 99%. So my standard deviation is going to be equal to, and what number should I plug in for my formula? The 55,000 minus the 74,000 over z sub 0.99, right? And then we're just going to punch that into our calculator and figure it out. Make sure you figure the top number first before you do your dividing. Yep, 8167.3. Okay.